Hello, this is Erica Puentes, QBA at Hudson Valley Community College. This video will be on mortgages, sinking funds, and perpetuities. It's the second video in the series, and I want to be sure that you have a handout for Unit 6. You should have your formula sheet, and you should review your PowerPoint presentation that I have made available on Blackboard. So I am going to jump over to the computer. This is the slide we left on, right here, 18. But before we get to that, I want to jump over to make sure you have the correct handout. There's your handout. Here's your formula sheet. And I want to be sure that you see these annuities perpetuity formula. Let's go back to our PowerPoint. So we were talking about mortgages and amortization schedules. And you will be doing an amortization schedule and understanding it on your Excel project. So let's look at slide 17. Again, this might be review. You borrow $150. That's your mortgage. But it's also your present value at 12% compounded monthly, 25 years to purchase a house. Show your financial standing after the first and second month. So I just want the amortization table for the first month and the second month. The first thing you always do, and I've mentioned this before, is you calculate N and I. N in this example is 25 years times 12 months. You will make 300 payments right here, 300 payments. I, just to review shortly, is your interest per period. In this case, it's monthly. So you have your 12% divided by 12 months, or your monthly interest will be 0.01. That's your first step. The second step, whether you're doing mortgages or a sinking fund, is you will calculate your payment. Here is calculate your payment given the present value in this case. So you have $150,000. I is 0.01 for 300 periods. Your payment is $1,579.84. You are going to pay that amount every single month for 300 months. Okay. So I asked you to fill out this amortization schedule. Your payment is the first column. It will remain the same, as I said, for 300 payments. Now, this payment is made up of two things. It's made up of interest you pay on your principal and your payment against your principal. You're paying down that $150,000 over 300 payments, so eventually you will owe nothing. So, to calculate interest, it's in this tiny print here, 1% times $150,000. On that first payment, you're paying $1,500 of interest. So of this payment right here of $1,579.84, $1,500 is going towards interest. Well, we subtract these two numbers. When we subtract those two numbers, we get $79.84. That is the amount that we're reducing the principal. We're reducing $150,000 by $79.84. So here, this last column where it says balance on loan, we don't owe $150,000. We owe $150,000 minus $79,084. So we only owe $149,920.16. So that's the balance on the loan after the first month. So we go along to the second month, and we're paying the exact same amount, right? The $1,579.84. However, this time our interest is calculated based on the balance of the loan, this $149,920.16. And if you see here in tiny print, we use that to calculate our interest, and our interest is reduced by 80 cents. So of this $1,579.84, $1,499.20 goes towards interest. If we subtract payment minus interest, now we're paying down $80.64 against our principal. So we don't owe $149,920.16. We owe that amount less the $80.64. So after we make our second payment, our balance on our loan is $149,839.52. These amortization schedules, you can go on Google and type in amortization schedule and get this information. Now, let's look at our payment right here. Our payment formula, our payment amount of $1,579.84. We find out that's our payment and we say, you know what, I cannot afford that payment. How can I reduce that payment? So you look at your formula here. Well, the first thing is this $150,000, your present value. How can you reduce that $150,000? Well, the first thing that jumps out is you can increase your deposit. Maybe you can go to a relative and say, hey, can I borrow $10,000 to reduce my payment? So instead of $150,000 present value, it's only $140,000. The other way to reduce your payment is just by buying a cheaper house, and then your $150,000 will be reduced. So there are two ways. The third way, if you notice in our formula, we have interest here 2 places. Well, this example, it was 12%, very high interest rate. You can shop around and get a lower interest rate. That's our third way. Our fourth way to reduce our payment is looking at the number of payments. And this was 25-year mortgage. If we extend it to a 30-year mortgage, that will reduce our payment. So the 4 ways, how can we reduce our payment looking at the formula, is shop around for a lower interest rate, increase the down payment, increase the term or the length of the mortgage. By the way, the max mortgage would be 30 years, or just buy a less expensive house. Those are 4 important key elements, and those would be only acceptable on your Excel assignment and a test. Now I'd like to go on to the next topic called a sinking fund. Okay? It's just the opposite of a mortgage. In a mortgage, we knew a present value, and we made a payment, and we reduced our principal until after 30 years, for example, there was nothing. We didn't own any money. Well, let's think about a sinking fund. A sinking fund is just an ordinary annuity with a known future value that represents some debt or obligation that's coming due. Sinking funds are used to redeem bonds or pay off debt. Well, let's say I know I'm a company and I know I am going to have to pay a bond. Many people have given me money, and I know that I am going to have to pay those people off in 5 years. So by law, I have to every month or every quarter sink money into a fund So in 5 years, I can pay those people back the debt I owe them. It's highly regulated, those sinking funds, but it's very typical redeeming bonds. Government does it, municipalities, and private industry issues bonds, but they know in 5 or 10 years they are going to have to pay back those bonds. So they have to start planning or sinking money into a fund to pay back that debt. So here's a sinking fund. You want to have $20,000 to purchase a car in 3 years. How much must be deposited every 6 months in an account that pays 7% semi-annually? Again, you find I, 7% divided by 2 because it's semi-annual. 3 years times 2 is 6. Your future value is $20,000. Now, very important, you're looking for the payment, right? You want to put money in an account. However, you're looking for the payment formula with a future value given. So here is our formula in PowerPoint form. You can find that formula. Let's look it up here. We're looking for payment given future value right there. We're looking for the payment given. I know I want to have $20,000 at the end of 3 years. Okay. So here's the formula. You substitute it in, and I want you to pause it to make sure you can put this in your calculator correctly. And your payment will be $3,053.36. Let's look at an amortization table for a sinking fund. So we start with 0 in the fund. Before we deposit any money, there's 0. From the previous slide, I said my payment is $3,053.36. So the amount in the fund at the end of the period, the first period, is $3,053. Okay, so here we are at the start of the period. We're going to go 6 months because that's what was defined in the problem. I have this $3,053.36, but I added on some interest rather. Okay, so I have a little bit more. I have $3160.23. I deposit money into the account, the payment that I was calculated. So at the end of the period, I have $6,021.13.59. You can pause to verify these calculations. So at the beginning of the period, the next day I have that amount. It's going to generate interest for 6 months. So here is my new amount in the bank. I make my payment in the bank where I'm circling it. And at the end of the period now I have $94.84.42. I would like you to pause the video and calculate for the next 3 periods, for the next 3 payment cycles. The amount in the end of the period, this last cell, should have $20,000. That's what I want. So please pause the video. You're back. Here are your answers. You can verify your answers. So that's a sinking fund. One last concept I want to go over in this chapter are called perpetuities. It's section 5.5 in your book, and it's an annuity. However, it has an infinite term. In other words, it goes on forever. The best example is scholarships. The principal, or the present value of the perp, is left unchanged, and only the interest is given away as a scholarship. Perpetuities are always present value. In your formula sheet, I define them at present value of a perp to define it from the other present value, to differentiate it from the other present value. Payment is the interest taken out at each period. I, again, is the interest per period. Very important formula for perpetuities is payment divided by I. This is on your formula sheet. Right here. Okay? So let's go to our first problem. You wish to provide a perpetual yearly scholarship of $1,500 with the first scholarship to be paid in 1 year. If money can be invested at 6%, how large must the scholarship be? So you want to give a scholarship of $1,500. That's the payment. That's the annuity. I is 6% divided by 1, or 6%. Our first step is to calculate the present value of the perpetuity. 1,500 divided by 6% equals 25,000. So let's look at this. I'm going to turn it into a slideshow. It'll help you a little bit more. So we deposit $25,000 today. We go along 1 year from now. We've generated $1,500 of interest, so we now have $26,500 at the end of the first year. We give away a scholarship of $1,500, so therefore we only have $25,000 in our balance. That money, we generate interest for 1 year, and we have $1,500 in interest for a total of $26,500 at the end of the first year. We give away a $1,500 scholarship, and we're left with $25,000 in the account. That $25,000 is going to generate interest during the second year of $1,500. We have a total of $26,500. We give away a scholarship of $1,500, and then we're left with $25,000. And you can see this goes on for infinity. This is when your payment or your scholarship is 1 year from now. Let's talk about a couple other situations. You wish to provide a perpetual yearly scholarship of $1,500 with the first scholarship to be paid in 1 year. If money can be invested at 6% compounded quarterly, how large must the grant be? If you notice, I've underlined, the scholarship is issued yearly, but your investment is compounded quarterly. They have to be the same terms. So therefore, this 6% quarterly, you have to determine the annual rate. How do you do that? Effective rate of return formula. Effective rate of return formula, we did that in the beginning of compound interest. So 6% compounded quarterly, we want to find the annual interest rate. I want you to think a little bit, and if we find this as an annual interest rate, will it be more or less than 6%? It should be a little bit more. So here is our effective annual interest rate. I substituted it in quarterly, so it's 4, my interest rate. So the annual interest rate I'm receiving is 0.061363. Go to 3 decimals. Okay? That's my annual interest rate. So now I can calculate. My payment's $1,500, my annual interest rate, and I can calculate the present value of my perp or what I would like to invest, $1,500 divided by the annual interest rate. And you'll notice I don't quite have to invest $25,000 this time because the interest is compounded quarterly. So I invest a little bit less than $25,000. It will be compounded quarterly, and yet I still will be able to give a scholarship of $1,500 a year. How much must an alumni donate to a college to provide a scholarship of $10,000 forever if the endowment can be invested 8% annually and the first scholarship is awarded today? Okay, so the payment's $10,000, interest rate 8%. It's invested annually and it's awarded annually. So the first thing you're going to do is calculate the present value of the perpetuity. $125,000. Okay, but you want it. So if you invest $125,000 today, you'll have $10,000 in interest in a year. However, you want to give away $10,000 today, now. So just add $10,000 on to the present value of the perp. So if you invest $135,000 today, you give away $10,000. That means you have $125,000 that's going to remain in the account for infinity, and you'll be able to award a $10,000 scholarship. Now, the next one is you want to give an annual scholarship of $10,000, 8% annually again. However, the first scholarship is awarded in 5 years. This is similar to the previous slide. So if I want to give the first scholarship in 5 years, that means in 5 years, I have to have $135,000 because I'm going to give $10,000 away in a scholarship and $125,000 will remain in the fund to generate interest for infinity. However, we have this $135,000 here, and we have to find the present value of it. We have $135,000 we need here, and we have to find the present value of it right here. So go to your compound interest, present value formula, or discounting. Here's our formula for 5 years. And today, we can invest $91,878.73 today, and we'll have $135,000 in 5 years. $10,000 of that we can give away as a scholarship, and the $125,000 will remain in perpetuity. So that ends Unit 6 on mortgages, sinking funds, and perpetuities. Okay, our last unit will be on bonds. And thank you for your time, and have a good day.